10 is it's not very good estimation of what you have. If you part half and half for training, half for test, then you will have a better idea of what is going on. If you only use half of the data for training, half of the data for testing, you will get a better estimate of what is the performance. Because 10 is not very good for estimating a Gaussian, like you are estimating a normal. You are doing an estimation of the normal in this 3 space. 10 points is almost not very good to do the estimation. I mean, you cannot trust very much the results because the estimation of a Gaussian function using only 10 samples is not very relevant.
If I do with 5 samples, you say
you can make 5 for cross-validation or 50-50 10 times, repeat it, and then the average of the result.
We have learned
there are many different methods for validation.
Recognition that method that is called take one out,
leave one out.
Leave one out is usually is a usual method for doing these things. We can question that method, but we are using one that is very good supported in the literature. We are using that method.
Yeah,
but this is one of the last that they are using.
But
maybe we can consider that this
but
method.
the leave one out have one problem.
Okay, but we are questioning now a method that is well established in the literature. Not a method we are using.
It's just to help you that
depending on the number of samples that you have, the size of the experiment.
But maybe this is a strategy to be used when you have not so much samples.
Yeah.
Because that increases the number of samples. That is something that is in the literature. They explain that. Yeah. And also they have that the best way to express the successful of your method or not successful of it is to draw this picture that we have drawn, because that is very used in pattern recognition method. We have checked that before.
Yeah.
And we are using a well-recognized method to obtaining maybe expanding the number of samples we have, and then we are expressing the result. Expanding in the sense that we are reducing the samples with the idea, and then we have used a method for representing the result that is also commonly accepted.
But
in that topic we cannot say nothing.
But for instance, I am pretty sure we use the nearest network, that is the simplest, the Bettino mass process. The nearest network in this 3-dimensional space, you will get probably the same results, even if not better.
No,
I think
that.
I don't know if you have checked that.
No, we have checked that.
You have to check that
yes,
it's
yes.
the nearest, but you have to compare. You have to compare with nearest network.
The paper and the work has a limit. Yes.
No, but because otherwise you don't know if this problem was very simple, clusters. To find the cluster, it was very hard to find the cluster.
We have assumed that maybe it must be contrasted from the statistical point of view. We have assumed that the distribution of the gates of the same person working more or less at the same speed are Gaussian. We have assumed that, but we have assumed, we have not tested, we have not made a contrast of hypothesis to check that because we have not enough data. Probably. I don't know, maybe asking that question for people with more knowledge maybe can help us to, but it is working because we can see how in the pictures, we work a lot with arrows. We represent the points and they are now maybe in a close clue of points. Okay, then come on to improve in other direction. That is the way of working.
Yeah, but to get this, working with these diagrams is because you have so many parameters to tune, and then you can start tuning the parameter until you get the clouds as you like. You get them together and not spread around. You know what I mean? Because there are several parameters underlying the method that you didn't talk about them, and you have to tune, like how long it's going to stay. What is the parameter for staying or changing? For state 1, state 2, or state 3, state 4.
You say that there are a lot of parameters. For example, the trapezoidal linguistic level.
Yeah,
the data is rescanned into the range by the standard deviation. And the linguistic levels are defined automatically.
But
So this is not tuned.
but you mean automatically like 3 parts, like a partition equally partitioned?
Equal partition.
Equal partition.
So
So
simple as that.
it isn't, there isn't only remind the time to stay.
The time to stay, but that also is automatic now. We have not,
Time to
does not
stay,
depend on the
the
data.
25% of the period of the game. So we don't tune that.
We don't tune nothing. That is function. Maybe we need to explain better, and I agree, how we get the result, but it is working. It is working with a very simple assumptions. We don't do nothing with the data. It is not, there is not a learning process, in fact. It is working, so worry.
No.
The question is how and why. Okay.
You said it is running, I still have a question. The question is, you defined a symmetry measure. So I think it was the right and the left foot, or vice versa, I don't know. And a similarity measure, you use the area below the acceleration. Symmetry. You use the area below the acceleration, I think, vertical or horizontal, I can't remember.
The rectangles are it. The picture of the rectangle.
So this is nothing else but comparing the speed in a certain point, and this, I don't think this is a good symmetry
The
measure.
speed is not affecting so much. In fact, we have tests that...
But the area below the acceleration, as far as I know, is the speed now.
Comparing the areas between a complete gay cycle, so symmetry is this area plus this area divided by this area plus this area.
The two areas are influenced by the speed, so they move in parallel.
But still, the graphs can be very different, and the area is the same. You want to compare essentially if the graphs are the same. So you want to compare functions and not the area below functions.
Compare the areas. The areas, yes. We compare. We said that the match is homogeneous. If the size of the area, in fact, the total area is repeating. That is if we go faster, maybe you are repeating even in the same proportion. We are checking that is true in the same proportion that you are working a bit slow.
Yeah, but what you want to do is compare if the two parts as graphs are the same, essentially, or similar.
Yes.
And then I think the area is not the best option.
Which is the result?
Because they can be very different and still have the same area.
You can have very big
Yes, but we are always speaking about the same. You and me are always speaking about the same.
Yeah, but this problem doesn't change.
Okay, I agree. I like to discuss with you this topic. Because we are always making summarizations, lost in information. For people who don't like absolutely lost information, but for me, the best approach when you focus or you face the complexity is you start lost in information as soon as possible. But of course, taking into account that you must avoid to lose the remarkable or the relevant information. That is the thing that we like to do. Of course, the area is a good topic. The area is a terrible summary. We are losing a lot of information. But is that information enough? That is the question. And that is
even if it is enough, but in many situations there is a simple solution that is even simpler than calculating the area, for instance.
Yeah.
And works in a better way.
Yeah.
I don't say that the area is bad, but maybe there are easier solutions.
We are checking that is one of the contributions of the work. The area is enough to distinguish between people. That is the other information that is out of peaks. There is a lot of information in the three acceleration we have. But at the end, we have concluded that maybe only with the areas, comparing the areas, is enough to distinguish between people.
Yeah, maybe. But if the training or if the whole set changes,
maybe in respect to them, because they said you need to do more work with more people. But in fact, until now, it is we get a very sharp separation between we can identify very clear the group of gates corresponding with one person.
Yeah, maybe this is because the data are very separated.
Yes, well, okay, but that means if you read the literature, you can see that in fact this problem of gate authentication is not solved really. So it is very interesting. It's the thing that we can tell you in this talk. We are working in this. Of course, we can.